Welcome to Chika Online Math.
Good day, viewers. Today we'll treat a binomial theorem. That's binomial formula for binomial expansion, like a plus b raised to power n. You know, a is a monomial, b is a monomial. So when you say a plus b or a minus b, whichever way, it's called a binomial because they are two. Because two is bi. Okay, so raised to power n. So this theorem concerns with how do we do this expansion. Okay, how do we do the expansion a plus b raised to power n? How do we get the formula for this expansion? Okay, now if we are to, if n is 0, a plus b raised to power, all raised to power 0 is what? 1, because any number raised to power 0 is 1. Okay, now what of a plus b raised to power 1? This is the same thing as a plus b, because any number raised to power 1 is itself. Okay, now what of a plus b raised to power 2? What will it give us? It is nothing but we do the expansion a plus b times a plus b. Okay, now let's try to multiply out by the side. Okay, we have a plus b times a plus b. Normal way we do expansion. Okay, normal way we do multiplication. B times b will give us what? B squared. B times a will give us what? AB. So this is a plus b plus b squared. Now let's use this, the second number a, to multiply. Okay, a times b will give us what? AB. And a times a will give us what? A squared. So this is a squared plus AB. So if you add from the back. So this is b squared plus AB will give us what? 2AB plus, now you bring down a square. Okay, so it's a square plus 2AB plus b square. So this is a square plus 2AB plus b square. Okay, now going further, we have done 2. Let's do a plus b raised to power 3. Okay, so we have a plus b raised to power 3. Now this is nothing but a plus b squared times a plus b. And a plus b squared, we have it this side as a squared plus 2ab plus b squared times a plus b. Okay, so let's do the multiplication by the side. We write them out, and what? A plus b. Okay, so we use b to multiply. We have b cubed here plus this one, b times 2ab will give us what? 2ab squared. Then b times a will give us, b times a square will give us what? A square b. Okay, next you use a to multiply. Okay, a times b square, we start from here, we have what? AB squared. Okay, now a times 2ab, we have what? 2a square b. Okay, and a times a square will give us what? A cubed. Okay, so if you add, we'll now add, we have b cubed here, then plus, then this one will give us what? 3ab squared. Okay, plus, then 2a square b plus a square b, that's a square b plus 2a square b will give us what? 3a square b. Okay, plus, then we bring down a cube. Okay, so this is nothing but what? A cube plus 3a square b plus 3ab square plus b cube. Okay, so we see the stress it took us to get a plus b raised to power 3. Now what if we are asked to evaluate a plus b raised to power 4, 5, 6, or 7? You understand? For instance, a plus b raised to power 7. You can imagine, when we will do all these things, we have gotten, you see the stress, we started from a plus b raised to power 1. Look at how long it took us to get a plus b raised to power 3. You can imagine the stress we have undergone before we get a plus b raised to power 7. Okay, so that is why this binomial theorem, binomial expansion, is very important. So we try to derive a formula that we don't need to pass through these steps. By the time we just substitute a, b, and all the numbers in the formula, we'll get a plus b raised to power 7 one touch. Okay, so let's write down the results we have gotten so far. Now observe, we have written them down. Now observe something. For n equal to 0, we have one term. For n equal to 1, the expansion gives us two terms, a and b. For n equal to 2, the expansion gives us three terms, a squared, 2ab, and b squared. For n equal to 3, the expansion gives us how many terms? The expansion gives us 4 terms, a cubed, 3a squared b, 3ab squared, and b cubed. Okay, so 0 gives us one term, 1 gives us two terms, 2 gives us three terms, 3 gives us 4 terms of 3 plus 1 terms, which is 4 terms. So n will give us what? N plus 1 terms. Okay, so we expect to have n plus 1 terms. Okay, and also notice something. A plus b raised to power 1 is a plus b, which is like a raised to power 1 plus b raised to power 1. Now a plus b squared is what? It starts with a squared and ends with what? B squared. A plus b cubed starts with a cubed and ends with b cubed, with other terms in between. Okay, so for n equal to 4, we expect that we will have a plus b raised to power 4 equal to, it will start with a raised to power 4 and end with what? B raised to power 4, with other terms in between. Okay, so how do we get these terms in between? There are many ways with other terms in between. Now notice another thing. The power of for a plus b squared, for instance, it starts with a squared, then the next power of a is a, or a raised to power 1. Okay, then in the third term, which is b squared, you can say it is b squared times a raised to power 0. So you have, so the power decreases by 1. See, a squared, that's power of a here is 2, followed by 1, followed by 0. Okay, and what of b? For what is the power of b in a plus b squared? The first one is a squared, or a squared b raised to power 0. Okay, so this one is b1, then b2. So power of b, it starts with 0, this one 1, this one 2. So as power of a decreases, power of a will start from n, you understand, and decrease to 0, while power of b stands for 0 and increases to n. Okay, look at a plus b cubed. It starts with a3, then goes down to a squared, then the next one is a raised to power 1. Okay, and the last one is what? A raised to power 0 or 1. Okay, because you know, if you use 1 to times anything, it's as good as, so if you use a raised to power 0 is 1, so a raised to power 0 b3 is still the same thing as b raised to power 3. So we have not changed anything. Okay, so now for a plus b raised to power 4, we have this. So how do we get these terms in between? Okay, it happens that there are two ways of getting these terms in between: Pascal triangle and the combination method. Okay, now what is a Pascal triangle? Before we delve into Pascal's triangle, let's observe the coefficients of the expansion we have gotten so far. The first one, for n equal to 0, we have the coefficient 1. Okay, for n equal to 1, the coefficient of a raised to power 1 is 1 here. Okay, And the coefficient of b raised to power 1 is 1. So 1 and 1. So we have 1, 1. Now, for n equal to 2, the coefficient of a square is what? 1. The coefficient of the second one, 2ab, is what? 2. The coefficient of the third one, b square, is what? 1. Okay? Now, what of a plus b raised to power 3? The coefficient of a raised to power 3 is 1. The coefficient of 3a squared b is what? 3. Then the other coefficient is what? 3. And the last coefficient, that's the coefficient of b raised to power 3, is 1. Now observe something. You see the way these numbers are. They look like what? Triangle. Okay? So it is because they're in triangle form. Okay? That's why we call it Pascal's triangle. So let's write down these coefficients and look at it once again. Okay, so notice that in this Pascal's triangle, the first one is for n equal to 0. N equal to 0. Second one is for n equal to 1. Third one is for n equal to 2. And fourth one is for n equal to 3. Okay? Now, observe something. In the Pascal's triangle, it always starts with 1 and ends with 1. Okay? Now, how do we generate these numbers? Look, for these 2, for instance, for n equal to 2, the term in the middle, that's 2, is gotten by what? Adding this 1 and this 1. So this 1 and this 1, if you add it, it gives you 2. Okay? Now for n equal to 3, how do we get, after the first term 1, how do we get the second term 3? Okay? We add this 1 and 2, you get 3. Okay? For this one, for this 3, well, how do we get it? We add this 2 and 1, we get 3. Okay? So for n equal to 4, to obtain the equations for n equal to 4, what we simply have to do is we start with 1, we end with 1 to make it maintain the triangular pattern. Okay? Then this 1 plus 3 will give us what? 4. Then 3 plus 3 will give us what? 6. Then this 3 plus 1 will give us what? 4. Okay? So we see how it is easy to generate. So let's use this Pascal's triangle, okay, to evaluate a plus b raised to power 4. Okay? So we have a plus b raised to power 4 equal to the coefficient of the first term is 1. You see 1, 4, 6, 4, 1. We use it 1. And the power of a will start with a raised to power 4. Then b is what? B raised to power 0. Plus, then we pick the second term. And the coefficient is what? Is this 4. Okay? We'll pick 4. So we have what? 4. Then the power of a will decrease by 1. So here is a raised to power 4. So this one will be a raised to power 3. And the power of b will increase by 1. That's b raised to power 1. Okay? Next, we pick this for the third term we pick 6. Okay? So we have what? Plus 6. Then power of a will decrease by 1. So we have a square here. And power of b will increase by 1. So we have b square. Okay? Plus, then we pick, for the fourth term, we pick the coefficient 4. Okay? So we have what? 4. Then power of a will decrease further by 1. So we have a raised to power 1 here. And power of b will increase by 1. So from 2 it will jump to 3. Okay? Plus, for the last time, we pick the coefficient 1. Okay? So we have what? 1. Power of a will decrease by 1. So we have a raised to power 0. And power of b will increase by 1. We have a raised to power 4. So if we simplify further, b raised to power 0 gives us 1. So we have 1 times a raised to power 4 times 1. So a raised to power 4 plus. Then this one will give us what? 4a cubed b. Okay? Plus. Then this one is 6a squared b squared. Okay? Plus. Then this one will give us what? 4a b 3. Then for the last one, a raised to power 0 is 1. So 1 times 1 is still 1. And 1 times b4 is b4. So it's plus b raised to power 4. So if we are asked to obtain a plus b raised to the power 5, okay, what we have to do is, in the Pascal, using Pascal triangle, what we have to do is, in that Pascal triangle, we extend it further, okay? So remember, we start by 1 and ends with 1, okay? Then we add 1 and 4, you get 5. Then add 4 and 6, you get 10. Add 6 and 4, you get 10. Add 4 and 1, you get 5. So the coefficients will be what? It will be 1, 5, 10, 10, 5, and finally 1, okay? Next, let's look at the second method called the combinatorial approach, or the combination method. So this is the binomial expansion using combination method. So we have summation r equal to 0 to n of what? N combination r, a to power n minus r, and b to power r, okay? Now, what is n combination r, okay? N combination r is nothing but what? N factorial all over r factorial times what? N minus r factorial, okay? Let's use this combination method to evaluate a plus b raised to power 5, okay? So we'll be having what? A plus b raised to power 5 equal to what? You start with, so if you go to this formula, you start with what? You substitute n equal to 5. So you have what? Summation r equal to 0 to 5. 5 combination r, a to power what? 5 minus r, b to power what? R, okay? Now, what will this give us? So let's write the sum explicitly, okay? For r equal to 0, we have what? 5 combination 0, then a to power 5 minus 0, which is 5, and b to power 0, plus, for r equal to 1, we have what? 5 combination 1, a to power 5 minus 1, which is 4, and b to power r, which is what? 1. Then for r equal to 2, we have what? 5 combination 2, then a to power 5 minus 2, which is a to power 3, and b to power r, which is what? 2, okay? Plus, then for r equal to 3, we have what? Let's continue this side. We have what? 5 combination 3, a to power 5 minus 3, which is 2, and b to power r. And what's our r? 3. Plus r equal to 4. So we have 5 combination 4, then a to power 5 minus 4, which is 1, and b to power r, which is what? 4, okay? Plus, the last one is r equal to 5, okay? So we have what? 5 combination 5, a to power 5 minus 5, which is 0, b to power r, which is what? 5, okay? So let's simplify this. 5 combination 0 is nothing but what? 5 factorial all over 0 factorial, 5 minus 0 factorial. So this is what? 5 factorial over 0 factorial is 1 factorial. 5 minus 0 factorial is what? 5 factorial. So 5 factorial will cancel 5 factorial. So this is what? 1, okay? So we'll be having what? 5 combination 0, which is 1, then a raised to power 5, b raised to power 0, which is what? 1, okay? So we can omit it because it's 1. Plus, next we have 5 combination 1. So let's evaluate 5 combination 1. 5 combination 1 is equal to what? 5 factorial all over 1 factorial, 5 minus 1 factorial. So this is what? 5 factorial over 1 factorial is 1. So you can just write 1 times 4. 5 minus 1 is what? 4 factorial. So this is 5 factorial over 4 factorial. And what is 5 factorial? 5 factorial is nothing but 5 times 4 factorial, all over 4 factorial. So 4 factorial will cancel 4 factorial. So this leaves us with the number what? 5, okay? So 5 combination 1 is 5. So we substitute here, we have what? 5 a raised to power 4, okay? B, because b raised to power 1 is b, plus. Next, we consider 5 combination 2. So let's evaluate 5 combination 2. 5 combination 2 is nothing but what? 5 factorial all over 2 factorial into 5 minus 2 factorial. So this is what? 5 factorial all over 2 factorial. Then what is 5 minus 2? Is 3. So 3 factorial. So now what is our 5 factorial? 5 factorial is nothing but 5 times 4 times 3 factorial, okay? All over 2 factorial times 3 factorial. So 3 factorial will cancel 3 factorial, okay? So this leaves us with what? 5 times 4 all over 2 factorial. And what's our 2 factorial? 2 factorial is nothing but 2. So if 2 divides, we have 1. And if 2 divides 4, we have 2. So 5 times 2 is what? 10. So we substitute 10, okay? Then this is what? A3 and B squared, okay? Plus, then next we have 5 combination 3. So let's evaluate 5 combination 3. 5 combination 3 is nothing but what? 5 factorial all over 3 factorial times 5 minus 3 factorial, okay? Which is what? 5 factorial all over 3 factorial. And what is 5 minus 3? 2 factorial, okay? Now, if you notice, this is the same thing with this, okay? So eventually we'll get the same answer we got in 5 combination 2, which is what? 10, okay? So 5 combination 3 gives us 10. So we'll be having what? 10 a squared b3, okay? So next we compute 5 combination 4, okay? So what is 5 combination 4? 5 combination 4 is nothing but what? 5 factorial all over 4 factorial times 5 minus 4 factorial. So this is what? 5 factorial all over 4 factorial times what? 5 minus 4, which is 1 factorial, okay? Now notice something. When we did 5 combination 1, we got 5 factorial all over 1 times 4 factorial. And in this same thing, we are getting 5 factorial all over 1 times 4 factorial. So they're the same thing. So we get the same thing, the same answer we got in 5 combination 1, which is what? What's the answer we got in 5 combination 1? It's nothing but the number 5, okay? So 5 combination 4 still gives us 5, okay? So since we got 5 combination 4 equal to 5, we'll substitute it in our answer. We'll be having what? Plus 5 a raised to power 1, which is a, b raised to power 4, okay? Plus the last one is 5 combination 5. So 5 combination 5, a raised to power 0, b raised to power 5. So let's evaluate 5 combination 5, okay? So 5 combination 5 is equal to what? 5 factorial all over 5 factorial times 5 minus 5 factorial. So this is what? 5 factorial all over 5 factorial. And what is 5 minus 5? 0 factorial. So this is 5 factorial all over 5 factorial times 0 factorial. But what is 0 factorial? 0 factorial is nothing but 1. So we'll be having 5 factorial over 5 factorial. So 5 factorial can cancel 5 factorial. So this leaves us with the answer 1. Okay, so 5 combination 5 is what? 1. So we substitute it in our result. Okay, so we're having what? 1 a raised to power 0, which is same thing as 1. Okay, so we can remove e raised to power 0. Okay, so then b raised to power 5. So this answer is nothing but what? So a plus b raised to power 5 is nothing but 1a raised to power 5, which is what? A raised to power 5 plus 5a raised to power 4b plus 10a raised to power 3b square plus 10a raised to power 2b cubed plus 5ab raised to power 4 plus 1b raised to power 5 is same thing as b raised to power 5. Okay, so that is a binomial theorem. Okay, so in the next lesson we'll see how to use binomial theorem to do other expansions. Okay, so we'll see the application of binomial theorem in our next lesson. Thank you for listening.